So now that I know what Tim Woods looks like, where's the best place to look for him? All of these wastes can be found anywhere, but the best place to start looking for them is in the value stream. What's a value stream? Do you remember what the customer wants? Value! That is right. The best place to find where waste exists is where materials and information flow through your process. That is the value stream. Like a river. Exactly. This flow can be mapped out, observed, and measured. Once we know the process, then we can start to find the problems and opportunities. Yes, and those opportunities live in the value stream. The value stream starts when a customer orders a part and ends when we get paid from that customer. Well, that covers a lot of ground. It certainly does, and it can become very complex. However, we can break the value stream down to focus on a specific area. As a matter of fact, that's the first step, determining the scope of the value stream. So if I wanted to focus on one process, I could do that? Yes. Determine where you want the value stream to start. This is typically considered the supplier. For example, say we have a machining department that uses parts that are produced by the cutting department. So the cutting department would be the supplier, and that is where we would start our value stream. Okay, but where does it end? It ends with the customer. Let's call that the assembly department. Now that we know where the value stream starts and stops, we can begin to map out the process steps. We could use drilling, deburr, and tapping as the process steps. That works. With the scope defined, now we can go to the shop floor and start collecting information. We need to learn things like what's the customer's daily demand and how is that communicated. For each station, we need to know things like the number of operators, the cycle time, the uptime. And we also need to know how much inventory there is at each step of the process. Using this information, we can now build our value stream map. Man, that looks complicated. It can be, but let's take a closer look at how to read it. We always start with the customer.
We can see that the daily demand is 300 pieces, and a report goes back to production control each day. We also see how much materials we are receiving from our supplier, the warehouse. Since our daily demand is 300 pieces and we have 900 pieces in inventory, the wait time is 3 days.
Hold on there. What's this wait time? That is a good question. Wait time is simply how long material, or work in process, sits in inventory before it's actually used. To calculate this, you divide the inventory by the daily customer demand. Well, that makes sense. But we got trouble right here. If we're using 1,500 pieces a week, we're only getting 1,000 a week from the warehouse. That ain't enough.
That's a good catch. Now we can add a Kaizen burst, or improvement opportunity, to our map. For each station, we now look at how much time we actually spend working on the part versus the wait time.
I get it. Drilling spends 72 seconds actually working, then the part sits there for 0.21 days.
Exactly. Now, the number of operators may change the process time, but we can see what is going on across the entire map. Do you notice anything?
You bet. Tapping has the longest cycle time and the worst uptime. Plus, they got a high defect rate. Man, that sounds like a recipe for disaster. Could we add one of those Kaizen things here?
Absolutely. Now we have something we can work on to make our process better. We can even look at how information flows in the system.
Wow, a value stream map can be a powerful tool. But what's that stuff down at the bottom about processing time and inventory time? That section shows us how efficient our process flow is. To calculate this, add up the process times in the white boxes. That gives us 182 seconds that are needed to make each part. Got it. Now we add up the wait times between each station. That gives us 3.78 days. But we need to convert that to seconds. We're only running one shift for 8 hours. So we multiply 8 times 3,600 times 3.78, and that gives us just over 13,000 seconds. Okay. Now, we just calculate the process flow efficiency by dividing the process time by the wait time. In this case, we get 1.33% of efficiency. 1.33%? Well, that ain't nothing. How do we make it better? First, we address the Kaizen bursts or opportunities that we found when we created the value stream map. But to go further, we're going to have to look at the next principle of Lean, creating flow. How do we do that? That is a video for another day.
Thank you for watching this video. If you found it interesting, please click the like button. If you want to see more like this, please subscribe. It really helps out the channel.